What if I told you that just 3 days ago, a piece of a SpaceX rocket about the size of a school bus smashed into the surface of the moon at over 400 miles per hour, and there was absolutely nothing anyone could do to stop it? No engines to fire, no astronaut to steer it, no last-second miracle. Just gravity, silence, and a slow, invisible slide toward disaster that took 18 long months to complete. Before we go any deeper into this wild story, do me one small favor. If space, science, and things that sound impossible but actually happened are the reason you clicked on this video, hit that like button. Drop the word moon in the comments so I know you are really here, and subscribe if you have not already, because the details coming up in the next few minutes will change the way you look at the night sky forever. Now let me take you back to a cold morning on January 15th, 2025. The place was the Kennedy Space Center in Cape Canaveral, Florida. A SpaceX Falcon 9 rocket stood tall on the pad, and this one was carrying something unusual. Not one lunar lander, but two, from two different companies from two different countries, all riding into space together on the same rocket. One of these landers was called Blue Ghost. It was built by an American company known as Firefly Aerospace. The second lander was named Hakuto R, and it did belong to a Japanese company called I-Space. Two spacecraft, two dreams, two entirely separate missions, all packed into one machine reaching for the moon. It sounded almost casual when the SpaceX team talked about it. Just another Tuesday, just another launch. That is how much this company has changed the space industry. Missions that once felt impossible now feel like routine deliveries. But what happened next? No one, not the engineers, not the scientists, not even the sharpest minds in space tracking could have imagined. After the launch, both landers separated from the rocket upper stage and began their own quiet journeys toward the moon. Blue Ghost actually made it. It landed on the lunar surface and spent 14 full days doing exactly what it was designed to do. That was a huge win. The Japanese Hakuto R lander, sadly, did not manage a successful touchdown. It failed during the landing attempt. That was a heartbreaking loss. But this is where the story takes a strange twist that most people never heard about. After the rocket, upper stage did its job. After it pushed both spacecraft on their way, it had nothing left. No fuel, no purpose, no way to come home. It became something scientists call space junk, just a hollow metal tube, weighing about 8,800 pounds, roughly 4,000 kilograms, stretching close to 39 feet long and about 13 feet wide. That is not a tiny piece of trash. That is basically a full-sized school bus, floating alone in the darkness with no one at the wheel. Now, normally when a Falcon 9 upper stage finishes its mission, it stays close to Earth. Gravity pulls it back down into the atmosphere. It burns up. Gone. Case closed. But this particular upper stage was pushed much farther out, closer to the moon than usual, and that changed everything. Because out there, far from home, gentle but powerful forces begin to whisper against every object floating in space. The pull of the sun, the pull of Earth, the pull of the moon itself. And there is one more thing most people never even think about. Sunlight. Yes, real sunlight. Light itself pushes against objects in space. Scientists call it radiation pressure. It is soft, it is barely noticeable. But over months, over a year, over 18 full months, that gentle push adds up. And in this case, it slowly, silently guided the rocket stage onto a new path. And that new path had a destination. That is where an astronomer named Bill Gray enters the picture. You have probably never heard his name before. He is not a Hollywood scientist. He does not run a giant lab. He works quietly, mostly alone, tracking objects in deep space, the far-out ones that most tracking systems do not bother with. For nearly 30 years, Bill Gray has done this work. He even built the software that helps tell the difference between real asteroids and pieces of human-made junk drifting through similar orbits. When big sky surveys spot something strange, they often call him to ask what they are looking at. In September of 2025, Bill Gray started noticing something odd. He saw that the Falcon 9 upper stage was drifting on a trajectory that did not look right. He ran the numbers. Then he ran them again. Weeks passed. Every check gave the same chilling answer. This rocket stage was heading straight for the moon. There was no engine to fire, no fuel to burn, no steering, no signal, no way to change course. It was locked in. It was going to hit. And here is the part that surprised me the most. Bill Gray was not panicked. He was not rushing to warn the world. He told journalists, calmly, that he had been watching for something like this for about 20 years, ever since large pieces of debris started ending up in orbits that could theoretically reach the moon. If anything, he was surprised it had not happened more often. Before this crash, only two objects had ever been confirmed to have accidentally hit the moon. The first was back in 2022. This one would be the second. Wait, quick pause. If you're already this deep into the story, I want to ask you something real quick. Do me a small favor, tap that like button one time. It might sound tiny, but it genuinely helps this channel reach more curious minds like yours. And if you are new here, hit subscribe. because the second half of this story gets even more surprising. Now let us keep going. As the months rolled on, Bill Gray predictions became sharper and sharper. The date, the time, and the impact point kept getting more precise. Finally, everything pointed to one exact moment, 6:35 in the morning, Universal Time, on August 5th, 2026. That is 1:35 in the morning, Central Daylight Time in the United States. The predicted crash site sat near a spot on the moon called the Einstein crater. It was near the western edge of the moon face as we see it from Earth. Scientists around the world snapped to attention. This was not a disaster to prevent. This was actually a rare gift. Think about it. A known object of known size, of known weight, hitting the moon at a known time, at a known location. That kind of setup almost never happens in astronomy. When natural asteroids hit the moon, they arrive without warning. Nobody has time to prepare telescopes. Nobody knows where to look. But this one was different. This one was circled on the calendar months ahead. On July 17, 2026, a research team published a full scientific paper on how to observe this event. They laid out the best angles, the best timing, and which telescopes should get involved. Just 10 days before impact, on July 27th, another team released their own paper. They were from the University of Texas at Austin. They built a detailed model of what the impact would look like. They predicted the main dust plume would rise between 45 and 60 meters above the lunar surface. They estimated the cloud would spread outward about 113 miles in every direction. And they said the plume would shine much brighter than the dark space around it for the first several minutes, especially through high-speed telescope cameras. The lead researcher, a scientist named William Joe, gave one important warning to observers around the world. He said the real science was not going to be in that 1-second flash. He said most people would probably stop recording after they caught that bright spark. But the eject plume, the cloud of dust and material blasting out in every direction, that was where the true information lived. He wanted them to keep watching, keep filming, keep listening to the story the moon was about to tell. And then came August 5th, 2026. At exactly 6:35 in the morning, Universal Time, the moment finally arrived. In the Atacama Desert of Chile, sitting high in the mountains, the European Southern Observatory. A very large telescope was locked onto the target. Across the Americas, telescopes were pointed skyward. Amateur astronomers held their breath. Then it happened. That 4,000-kilogram hollow metal tube slammed into the lunar surface at around 8,700 kilometers per hour. That is roughly 5.5 kilometers every single second. There is no atmosphere on the moon to slow anything down. Nothing softens the blow, nothing pushes back. The force of the impact was equivalent to roughly 3 tons of TNT exploding on the surface. 3 tons, instantly, right there in the lunar silence. Within minutes, the European Southern Observatory confirmed what their sensitive instruments had captured. Inside the plume of material blasted off the moon, they detected chemical fingerprints of 2 elements, sodium and lithium. The sodium, scientists believe, came from the lunar soil itself. The moon's surface contains sodium compounds. When they get violently shaken by an impact, they release into space. But the lithium was different. Lithium is a well-known ingredient in the batteries that live inside rocket hardware. Scientists strongly believe that lithium came from the rocket itself. It came from the batteries that were still tucked inside that hollow metal shell, now vaporized into gas across the moon. Let that sink in for a second. A chemical fingerprint from both the moon and from the machine blended into one glowing cloud. It lingered in space for 5 to 10 minutes after impact. That is poetic. That is science and history colliding, literally. Just one day later, on August the 6th, the Korean Aerospace Administration shared a fresh set of images taken by South Korea lunar orbiter Danuri. That spacecraft had been carefully moved into position to watch this exact event. It performed 8 separate imaging sessions. One image was taken about 30 minutes before impact. Then 7 more images were taken after. When scientists lined up those pictures side by side, something unmistakable appeared. In the after images, there was a dark streak. It was on the lunar surface and simply was not there before. A brand new mark, a fresh wound on the moon. The exact size of the crater has not been fully measured yet. Early estimates suggest it will be roughly 20 to 30 meters wide. That is between 65 and 100 feet across. That may sound big, but it is actually smaller than you would expect for something of that weight. That is because the rocket stage was hollow. When a hollow object hits at high speed, the energy of the impact spreads out differently. This is compared to when a solid, dense object hits. That is part of why scientists are so excited. They want to understand exactly how human-made hollow debris behaves when it slams into the moon, because that data will matter more as space becomes crowded. NASA Lunar Reconnaissance Orbiter has been circling the moon for years and has photographed dozens of craters over its long career. It is now being aimed at this new impact site. Scientists expect to soon receive high-resolution images that reveal the crater in detail. This is just like what happened in 2022. Speaking of 2022, let me take you back for a moment because that story is the closest cousin to this. Back in March 2022, Bill Gray tracked another piece of rocket debris on a collision course with the moon. At first, there was confusion about where it came from. Some thought it was an old SpaceX Falcon 9 upper stage. Later, further analysis suggested it was actually part of a Chinese Long March 3C rocket launched all the way back in 2014. Either way, on March 4th, 2022, that piece of hardware hit the moon. When NASA Lunar Reconnaissance Orbiter finally captured images, everyone was stunned. It was not one crater, it was two. Two overlapping craters, each about 100 feet across, sitting right next to each other. They formed a strange double-impact scar. Scientists had never seen anything like that from a natural impact. The best explanation was that the hollow rocket body was unevenly balanced with heavy engines on one end and lighter structure on the other. It had struck the surface in a way that released its energy in two nearly simultaneous points. That is the kind of weird, unexpected, thrilling result you only get when reality itself decides to hit the moon. Now, with this new 2026 impact, scientists have better instruments, better preparation, and better before and after photography. And what they learned from this one accident may end up shaping the future of human space travel more than anyone expected. Because here's the bigger picture that this crash quietly fits into. NASA, SpaceX, China, and other space agencies are all racing to the moon. They want to send humans back in a serious way. NASA Artemis program already announced its crew for Artemis 3rd, scheduled for 2027. That mission plans to land astronauts on the moon's south pole for the very first time in history. And SpaceX is a huge piece of that puzzle. SpaceX Starship is the largest and most powerful rocket ever built by human hands. It is the vehicle chosen to actually land those astronauts on the surface. Just last October in 2025, SpaceX successfully launched and landed its flight. It was the 11th Starship test flight, splashing down in the Indian Ocean. That flight was seen as a major step toward carrying real crew members. But before humans stand on the moon again, scientists need to deeply understand the ground under those boots. They need to know exactly how dust reacts when something hits. They need to understand how craters form and how debris spreads. They need real information, not just computer simulations. Hold on for 1 second. I want to say something quickly. This channel exists because curious people like you keep watching. So if you are finding this story wild, please share this video with just one friend. Just one. That one share is the fuel that keeps us telling stories like this. And if you have not yet, ring the notification bell. This ensures you never miss the next big space mystery. Okay, back to the story. When astronauts finally walk on the moon in 2027 and beyond, and when future missions eventually build outposts, land supply rockets, and set up long-term habitats, impacts and debris become real safety concerns. An astronaut cannot be struck by a piece of ejected lunar rock flying at high speed. Equipment cannot be shattered by falling debris. Habitats cannot be punctured by unexpected material flying from a nearby impact. That is why data from real impacts is priceless. William Joe, the lead scientist from the University of Texas team, said it perfectly. He explained every future thing depends on these models. This depends on strong models of impact ejecta and plume dynamics. This crash, as unfortunate as it sounds, just handed scientists a treasure chest. It is a chest of real-world data to test those models against. Data that simply did not exist before and now suddenly does. But there is another side to this story that we cannot ignore, no matter how thrilling the science is. Juliana Chiayaman, who serves as SpaceX Director of NASA Science and Dragon programs, spoke to reporters just 2 days before the impact. Her words carried weight. She admitted that the trajectory leading to this crash was unintentional but unpreventable. This was because the rocket remaining fuel simply could not override the natural forces guiding it. That was an honest, respectable statement. SpaceX did not try to hide behind excuses. They did not spin the story, they admitted the truth. The rocket ran out of fuel, drifted for 18 months, and gravity decided the rest. Bill Gray, the same astronomer who spent months predicting the impact, also gave a quote that struck a chord with a lot of people. He said this event did not present any immediate danger, but it did shine a light on a certain carelessness and disposal. He was referring to how leftover space hardware is disposed of. Then he added something that has been echoing across science circles ever since. He said things are getting crowded up there. Take a moment and imagine that. Right now, there are hundreds of thousands of pieces of debris. They are orbiting the Earth. Most are small, some are large, many are tracked, but others are barely watched at all. This is especially true for the ones drifting far out in high orbits. Bill Gray himself has admitted he is essentially the main person paying attention. He called high-altitude junk mostly ignored, except by him. Think about that for a second. One man, watching the sky, tracking pieces of forgotten hardware. making predictions that governments and multi-billion-dollar space companies later confirmed to be true. And he is mostly doing it quietly, without applause, without spotlight. The rules about space junk disposal are not nearly as strict as they should be. For objects in low Earth orbit, there are basic guidelines. Spacecraft need to re-enter the atmosphere within a certain time. That helps reduce clutter closer to home. But for objects that end up much higher, the rules are loose, unclear, and rarely enforced. And here's the worrying part. Space is about to get much, much busier. SpaceX now launches dozens of rockets every year. Other companies across the planet are also ramping up their launches. China is dramatically increasing its rocket cadence. Private companies from multiple countries are sending landers and orbiters to the moon at record speeds. Each launch leaves something behind: upper stages, fairings, and hardware of every shape and size. Most of it burns up safely in the atmosphere, but not all of it. Not the pieces that end up far out in deep space, drifting for months, sometimes years, quietly moved by gravity and sunlight until they collide. In 65 years of human spaceflight, only 2 accidental rocket impacts on the moon have ever been confirmed. That number sounds low, and honestly, it is remarkable given how much stuff we have launched. But that number will not stay low forever. The moon itself is about to become the busiest it has ever been in human history. NASA is planning crewed missions. China is too. Multiple robots and rovers are being scheduled. Commercial companies are lining up to drop landers on the surface. If space debris starts hitting the moon more often, and if any of it hits near active missions, the consequences could be very real. So this crash, as strange and dramatic as it sounds, is more than a viral news headline. It is actually a warning shot, a wake-up call in the softest, silent language space can speak. A school bus-sized rocket smashed into the moon 3 days ago. It carved out a brand new crater. It sent sodium and lithium gas drifting into the lunar sky in a plume that glowed for nearly 10 minutes. It was captured by a South Korean spacecraft. It was analyzed chemically by one of the most powerful telescopes in the world. And it was predicted, tracked, and documented by a tiny group of astronomers who work in the background far outside the world of viral trends. There is something almost poetic about this whole moment. A rocket built to launch 2 separate landers ended up going to the moon itself. It happened in the most unplanned way possible. It did not land softly. It did not complete a mission. It did not return home. It crashed. And it left a mark near the Einstein crater that will remain there essentially forever. Because the moon has no wind, no rain, no erosion, no weather to wash the past away. That crater will sit there for billions of years, long after SpaceX becomes a memory, long after Elon Musk is gone, long after every single person alive right now has faded from history. That crater will still be there, a silent, permanent record of an accident that was never supposed to happen. Right now, as we speak, scientists are staring at those before and after images from Danuri. They are studying the chemical patterns. They are waiting for the Lunar Reconnaissance Orbiter to pass over the site and beam back sharp new pictures. They are writing new papers. They are building better simulations and slowly polishing the models that will someday help protect real astronauts on real missions. That is the beauty of real science. It is not always neat. It is not always planned. Sometimes the biggest leaps come from accidents, a forgotten piece of hardware, 18 months of quiet drifting, whispers of sunlight and gravity moving it in slow motion. It felt almost invisible. Until one quiet morning at 6:35 UTC when it finally reached its destination. No mission, no crew, no press event, just momentum. And one astronomer, Bill Gray, watching the sky the way he has watched it for 30 years, mostly alone. He did not have a dramatic light bulb moment. He said the certainty came slowly, gradually, like a puzzle putting itself together over months. He kept running the numbers. He kept refining the trajectory. He kept watching. And in the end, he was right. On August 5th, 2026, the moon received a new crater. It was not the first, and it certainly will not be the last, but it may be the most watched, the most predicted, and the most useful crater the moon has ever received from human hands, because everything scientists learn from this event will directly shape how the humanity returns to the moon and how we build there. It will help us protect our astronauts, and how we try, harder than ever before, not to leave more of our trash behind. And maybe that is the real lesson buried in this whole story. Space is not endless in the way we imagine. It is not empty. It is not a distant playground where we can throw away our leftovers without consequence. Every rocket carries a small piece of responsibility. Every mission leaves behind a shadow. And every once in a while, that shadow catches up to us in a crater on the moon. It will outlive our entire civilization. So the next time you look up at that glowing white circle in the night sky, remember this. Somewhere near its western edge, close to the Einstein crater, there is a fresh scar. A quiet reminder that advanced machines can drift. A reminder that space belongs to no one, but the responsibility for it belongs to all of us. You are my kind of viewer. You did not just watch, you actually cared. So one last favor for me. Give this video a like if it made you think. Drop a comment telling me whether you believe there should be stricter rules for space debris, and share this with someone. Share it with someone who still thinks the moon is just a pretty background in the sky. And of course, subscribe to the channel. Because the next story I am working on may just change the way you look at the universe forever. Until then, keep looking up.